Imagine this, you're late for work, stuck in traffic, cursing time itself, and somewhere an astronaut is chilling in orbit, aging a few milliseconds slower than you. Yep, while you're stressing in traffic, they're literally time traveling. Welcome to the wild world of time and space, where reality plays by rules stranger than sci-fi, and the universe seems to enjoy trolling us. Time is weird. What is time? To Newton, time was like that one boring relative at family dinners, always the same, everywhere, no surprises. But Einstein came along and said, nope, time is flexible. It stretches, bends, and even slows down. Basically, Newton thought the universe had a Swiss watch. Einstein said, nah bro, it's more like a rubber band. Relativity, when time slows down, here's the kicker. The faster you go, the slower your clock runs. Astronauts age a tiny bit less in space. GPS satellites have to correct their clocks every day, or your Google Maps would send you into a lake. So yeah, relativity isn't just a nerdy theory, it's the reason your Uber driver actually finds your house. The arrow of time, we never see a broken egg reassemble itself. Why? Because of entropy, the universe's way of saying things fall apart. Deal with it. It's like your room. You clean it, and a week later, entropy has turned it into chaos again. That's the arrow of time in action. Is time an illusion? Some physicists think the past, present, and future all exist at once like Netflix. You're just scrolling through episodes one by one. So yeah, time might not be flowing at all. You're just binge-watching existence. Time travel, time dilation in space. Want to travel into the future? Easy. Just go near light speed. Problem, we can't. Solution, complain about it on YouTube. If you could hop on a near light speed spaceship, you'd come back after 10 years only to find Earth aged 10,000. Imagine leaving in 2025 and returning to find the year 12,025, where TikTok still exists. Terrifying. Wormholes, cosmic shortcuts. Einstein's equations allow wormholes, tunnels through space and time. Sounds awesome, right? Except they're unstable, need exotic matter, and might kill you instantly. Basically, cosmic doorways that say, enter at your own risk, no refunds. Time travel paradoxes. The grandfather paradox. Go back in time. Stop your grandparents from meeting. Congratulations, you just deleted yourself. Oops. Solution? Parallel universes. In one timeline, you're gone. In another, you still exist. It's basically the multiverse's way of saying, don't worry, we got backups.
Time and space are the twin scaffolds of reality, the invisible threads on which the tapestry of existence is woven. From the vast cosmic voids that stretch billions of light years across to the fleeting seconds we live through, time and space define everything we perceive, measure, and experience. They are both familiar and elusive, intuitive yet profoundly mysterious, shaping not only the universe around us but also the very essence of our consciousness. At its most fundamental, space is the three-dimensional expanse in which objects exist and events occur. We often take space for granted walking through a room, driving down a street, or gazing at the night sky, but the reality of space is far more complex than our daily experience suggests. Space is not merely an empty stage upon which matter performs. It is dynamic, pliable, and intimately intertwined with time. Albert Einstein's revolutionary insight in the early 20th century revealed that space and time are not separate entities but part of a four-dimensional continuum called space-time. This idea reshaped our understanding of the universe, showing that massive objects like stars and planets warp the fabric of space-time, and that gravity is a manifestation of this curvature. The nature of space at the largest scales is mind-boggling. Our universe is home to billions of galaxies, each containing billions of stars, separated by interstellar voids that are almost unimaginably vast. Between these galaxies lies dark matter, an invisible substance that neither emits nor absorbs light but exerts a gravitational pull, holding galactic structures together. Even more mysterious is dark energy, a diffuse force driving the accelerating expansion of the universe. These components challenge our intuitive understanding of emptiness. What we call a vacuum is actually a seething landscape of virtual particles, energy fluctuations, and unseen forces. If space is vast and intricate, time is equally enigmatic. In everyday life, time seems linear, progressing inexorably from past to future. Clocks tick steadily, calendars march forward, and we experience life as a sequence of events. Yet at the cosmic scale, time is not absolute. Einstein's theory of relativity revealed that time is relative depending on the observer's motion and the gravitational field in which they reside. A clock aboard a spaceship moving at near light speed will tick more slowly relative to a clock on Earth, a phenomenon known as time dilation. Similarly, near a massive black hole, time itself stretches and slows. These effects are not theoretical curiosities, they have practical implications. The global positioning system, for example, must account for both gravitational and velocity-induced time dilation to provide accurate positioning data. The concept of time also raises profound philosophical questions. Is time a flowing river, or is it a static dimension where past, present, and future coexist? Some physicists argue for the block universe theory, suggesting that all moments in time exist simultaneously and our perception of progression is an emergent feature of consciousness. Others emphasize the arrow of time, the one-way direction dictated by the increase of entropy, a fundamental principle in thermodynamics. Entropy explains why we remember the past, but not the future, why ice melts but never spontaneously reforms, and why time feels irreversible at the macroscopic level, even if the fundamental laws of Einstein's insights into spacetime also led to revolutionary predictions about the cosmos, such as black holes, regions of spacetime where gravity is so intense that nothing, not even light, can escape. Black holes are natural laboratories for understanding the interplay of space, time, and matter. Near the event horizon, time slows dramatically, and the geometry of space itself bends toward a singularity where our current laws of physics break down. Beyond black holes, theoretical constructs like wormholes, hypothetical bridges connecting distant points in spacetime suggest that the universe may be far more interconnected than we perceive. While wormholes remain speculative, they highlight the tantalizing possibility that time and space may be navigable in ways that defy our everyday intuitions. On a smaller scale, the quantum world reveals an even stranger nature of space and time. At the Planck scale, distances and durations billions of times smaller than atoms, spacetime may not be smooth and continuous but discrete and granular. Quantum fluctuations mean that particles can spontaneously appear and vanish, and entanglement allows instantaneous correlations across vast distances, challenging our classical notions of causality. Reconciling quantum mechanics with general relativity is one of the greatest challenges in modern physics, with theories such as string theory and loop quantum gravity proposing fundamentally new ways to understand the fabric of reality. Time and space are not merely abstract concepts. They influence our daily lives in subtle and profound ways. The technologies we rely on, GPS navigation, telecommunications, and even financial systems, depend on a precise understanding of spacetime. Astronomy, astrophysics, and cosmology reveal the past through the light of distant stars, allowing us to reconstruct the universe's history. The study of time and space also informs philosophy, inspiring questions about existence, causality, and the ultimate fate of the cosmos. Will the universe continue expanding forever? Will it collapse in a big crunch? Or does it exist in a multiverse, one bubble among countless others, each with its own spacetime structure? Humanity's relationship with time and space is also deeply psychological. We live within a temporal framework, planning for the future, reflecting on the past, and creating meaning in the present. We inhabit a spatial environment, navigating through cities, oceans, and landscapes, yet we are drawn to the cosmic scale, to the awe-inspiring vastness of the stars. This dual awareness drives exploration, innovation, and imagination. We build telescopes to peer billions of light years away, particle accelerators to probe the infinitesimal, and theories to reconcile the infinitely large with the infinitely small. In contemplating time and space, we confront both the limits of human understanding and the boundless potential of discovery. We realize that what seems permanent, our clocks, our coordinates, our daily lives, is but a small part of a grand, interconnected reality. Each moment and each location is a thread in the cosmic tapestry, interwoven with gravity, motion, and energy. Time and space are not merely containers of events. They are dynamic participants in the universe's ongoing evolution. The journey to understand time and space is ongoing. With every observation, experiment, and theory, we peel back another layer of mystery. Gravitational waves ripple across space-time, revealing cataclysmic collisions in distant galaxies. Quantum sensors probe minute fluctuations in the vacuum, hinting at deeper structures beneath reality's surface. Theoretical physicists explore multiverses, extra dimensions, and the unification of forces. Each discovery challenges assumptions, redefines limits, and opens new horizons for inquiry. Ultimately, time and space are more than physical phenomena. They are the very context in which existence unfolds. They connect the microcosm and the macrocosm, the fleeting and the eternal, the tangible and the abstract. Understanding them requires imagination, mathematics, observation, and philosophical reflection. As we gaze into the night sky or delve into quantum experiments, we are reminded that we are both inhabitants and explorers of this vast continuum. The more we learn, the more we realize the depth and richness of the universe and the profound ways in which time and space shape every aspect of reality. In this ever-expanding quest, humanity continues to probe the boundaries of knowledge. From Newton's absolute clock and Euclidean space to Einstein's relativity and quantum geometry, our comprehension of time and space has evolved dramatically, and yet mysteries remain. Dark matter, dark energy, the unification of forces, the true nature of time, and the ultimate fate of the cosmos all beckon us toward deeper understanding. Each step illuminates the interwoven fabric of reality, revealing a universe that is at once elegant, intricate, and astonishingly vast. Time and space are the stage, the actors, and the audience of existence. They are measured, experienced, and yet remain profoundly mysterious. Through science, philosophy, and human curiosity, we continue to navigate this continuum, unraveling its secrets and marveling at its complexity. In understanding time and space, we gain not only knowledge of the universe, but insight into our own place within it, fleeting, conscious, and infinitely connected to the cosmos we inhabit. And there you have it, a journey through the vast, mysterious realms of time and space. From the infinitesimal quirks of quantum mechanics to the colossal expanse of galaxies and black holes, we've glimpsed the threads that weave the very fabric of reality. Time is not merely a ticking clock, nor is space just an empty void. They are dynamic, intertwined, and constantly shaping everything around us. Understanding them challenges our intuition, stretches our imagination, and opens our minds to the incredible complexity of the universe. Every discovery, from Einstein's revelations about relativity to the latest insights into dark matter and gravitational waves, reminds us that the universe is far more mysterious and awe-inspiring than we can ever fully comprehend. And yet, despite all the questions that remain unanswered, one thing is certain: our curiosity, our drive to explore, and our ability to imagine the unimaginable are what make humanity unique. Each step forward in science is not just a glimpse into the cosmos, it's a mirror reflecting our own thirst for understanding and connection. If this video sparked your imagination, inspired wonder, or made you rethink the very nature of reality, then our mission is accomplished. Remember, time and space are not just distant cosmic concepts, they're part of your daily life, shaping every moment and every choice. Whether you're looking up at the stars or observing the smallest particles under a microscope, you are participating in the grand dance of the universe. So, if you enjoyed this deep dive into the mysteries of time and space, don't forget to hit that like button, share this video with fellow explorers, and subscribe for more journeys into science, the cosmos, and the extraordinary wonders that surround us. And be sure to click the notification bell so you never miss a chance to expand your mind with new discoveries. Until next time, keep looking up, keep questioning, and remember, the universe is not just out there, it's within you too. Every second you experience, every moment you ponder, you are part of this incredible continuum. Thank you for joining us on this adventure, and we'll see you in the next video, where curiosity meets the cosmos and the mysteries of time and space continue to unfold. And don't forget to like and subscribe and share with your friends and family. Stay tuned for next video. Take care,